Hi guys, today is a very exciting day because today you'll be writing your first program in C. You're going to write the hello world in C using two different methods. You're going to use the printf method and you're going to use the puts method, right? I am so excited about this. I hope you are too. If you are, let's get started. Okay, so we are simply going to write the hello world in C. The C program, all right? C program runs from the main function, right? What this simply means is that you need to have a function called main for your C program to run. What each individual component of this function means is that a function in C simply begins with a return data type, right? And then the name of the function, name of function, and inside parentheses you have parameters, and inside the curly braces you have blocks code, right? So what it simply means is the return data type is going to tell the compiler that this function is going to return X data type depending on the number on the kind of data type you specify. It could be an integer, it could be a character in form of a char. It could also be void, meaning it can be empty, it can be a struct, or any of those C data types, right? So, um, a basic Hello World C program is written using the return data type, the name of the function, right? And then calling a printf function or a put function, and then simply writing what you want to return. In this case, we are returning hello world to the console. So what simply happens here is that um, the compiler looks for the main function, and then it looks inside the block, and then it finds a printf function that tells it to print the hello world, right? The hello world here is simply the argument that has been passed to this printf function, right? This we are fortunate enough to have a printf function which is a built-in method in the C library, which helps us print or write things to the console. So this alone is enough to have a hello world printed on our console, but this function or method is lacking one thing, right? Now, how do we tell the compiler where to find the printf function? Because anyone can write a printf function. I can write a function and name it printf, right? So how do we tell the compiler, hey, I want you to look at this printf function inside this particular library? How do we tell that? So in C, to specify a particular library where the compiler looks for pre pre-built or built-in functions which are referenced or called in your program. What you simply do is to use the include statement, which is used to add header files to our program. So the printf function specifically is stored in the standard input output header of the C pre-built-in libraries. Okay, so with this we can simply copy and paste this in our command line, and we are going to have a beautiful hello world printed to our console, and voila, we've just written our first program that prints hello world. You can replace hello world with your name or whatever, it prints whatever you write in there. And also, if you've noticed, I added a backslash n here, right? Because a C program is a low level language, everything needs to be manually done, right? So the backslash n is me trying to tell a compiler that, hey, I want you to print hello world and move to the next line. I don't want you to grant me access to my command line on the same line where the hello world is being printed, right? So that is what the backslash n does. It simply jumps to a new line. Okay. So another way to print hello world on the console is to simply also use the include header because we want to use a method that is predefined in the input output header. And we also want to use the main function. Then we want to use inside the block. Now we are going to use the method called the put method, and then we are going to pass hello world, right? And then remember you terminate every statement in C with a semicolon. If you don't terminate your C statement with a semicolon, which specifies that this is the end of a statement, the GCC compiler is going to return an error. Okay, so now we have this simple program written inside a file called hello.c. Now, how do we run this file to get the expected output? So to do that, we we use the GCC compiler, right? If you don't have the compiler on your system, if you're using Linux, you can just type apt get install GCC, right? And that should install GCC on your machine. If you're using a Mac, I think it should be brew install GCC or something. You can just look that up on Google. It's a very easy command to do. And then, how do you use the GCC compiler? First, you need to check if GCC has been properly installed in your system. So, how you do that is you simply type GCC double hyphen version, right? And then hit enter. If GCC has been properly installed, you should see the version of GCC which you have installed on your machine. And I think for all Linux machines, GCC comes pre-installed in the machine, right? So to to run the hello world, the hello.c file, we can either type GCC and then append the name of the file, right? The only drawdown of this method is that when you hit enter, it leaves you with an executable called a.out, right? So um, to to give our executable a unique name, we can simply pass a flag -o flag to GCC, which simply tells GCC, hey GCC, I want you to compile the hello world. Sorry, I want you to compile the hello.c file, and I want you to give it the name hello, right? So once you type this GCC hyphen o hello or whatever name you want to call your executable, and then hello.c or the file you want to compile, and then you hit enter, it's going to generate an executable called hello or whichever name you input into the space where I have hello there. And then that way you can move further to run the hello file using period forward slash and the name of the file. Right? Once you do that and you hit enter, automatically you should have hello world printed on your console. Remember, the GCC compiler compiles our source code through four different stages: the pre-processing stage, the compilation stage, the assembly stage, and the linking stage, right? So the pre-processing stage simply generates some source files, some source codes, sorry. And then if you have any need to work with the pre-processing stage, you have to redirect the um, the source codes to a file, right? So how do you how do you generate um, the pre-processing source codes? So you simply use the hyphen e flag. Simply append the hyphen e flag to GCC, and then the name of the file, something like GCC hyphen e, and then the name of the file dot c, and then this without if you don't append this to the file, it's going to generate some source codes and then display it on your console, right? To avoid that, you can simply redirect this to a file. You can give it a name, C, hello, or whatever name you feel like to give to the file, right? Then, if you want GCC to stop the compilation at the compilation stage, simply use the hyphen s flag, right? This is going to generate a file with .s extension, right? Then if you want your compilation to stop at the assembly stage without linking your source files to generate an executable, you simply use the hyphen C flag, right? The hyphen C flag generates object files. The assembly stage generate object files with .o extension, right? Files generated from the assembly stage can be referenced when you're working with when you want to create static or dynamic libraries. So we'll talk more on dynamic or static libraries in the future. So let's jump into the console and practicalize what we've done so far. So we are currently in my terminal. I'll move further to create a file called hello.c, and then I'll include a header, a standard input output.h header, which simply tells the compiler where to look for when it comes in contact with certain methods it's unaware of. So I'm going to specify the return data type of the main function, and then the main function is not going to take any argument, so I'll include void or I just leave it empty, and then open and close the curly brace, and then I'll call a printf function, which is simply going to print hello world and a backslash n. And finally, I terminate the statement with a semicolon, right? So what simply happens here is that I included a header file, right? The header file, which is the standard input output header, right? I declared a return data type, right? I specified a return data type. I gave my function a name, which is main, because the C program requires a main function to run. The main function can call every other function, right? And then inside the block of the main function, I simply call the printf function, which is going to print hello world, and then jump to a new line using the new line character. And then finally, I terminate the statement using a semicolon. So let me save this, and then I'll also check the version of GCC I have on my machine. So if you use the GCC double hyphen version, you should see a version of GCC installed on your machine. At the time of this recording, I have GCC version 9.4.0 installed on my machine. Yours can be different, but it does the same thing, right? So you can see I have the hello.c file here. So I'll move further to compile this file using the first method, gcc and the file to convert. So if I hit enter, if everything goes well, it should generate an executable with the name a.out. So okay, so it generated a, an executable called a.out. So how do we run this executable? Like I said, you simply use period forward slash and the name of the executable. So once you hit enter, you can see that hello world is out. Okay, so let's do something more intriguing now. Um, we want to give the file a name instead of having the name a.out. We want to give it a name called hello. So we simply use the hyphen o flag and then the name of the file. This simply means we are trying to tell GCC, hey GCC, I want you to compile the file hello.c, but I want you to give it a name hello. So that's simply what the hyphen o flag does. It gives the executable that is going to be generated by GCC a name. So let's go ahead and hit enter again, right? And once you hit ls, you can see now we have the file hello. So if I run hello, we should still have the same hello world. If I run a.out, we should still have hello world, right? So that makes sense, right? So let's try modifying hello.c to print hello world using the second method, which is the puts method, right? So inside here, we can simply erase the printf and simply include puts, and then just run the program. The same thing, we have the header, we have the return data type, we have the name of the function, and then this time we are calling the function a pre-built function called the puts function, and then we are passing an argument hello world to it, right? So if we save this and then try to run this, giving it a name hello world, right? And then if we run it and see, we now have the file hello world. So if we run hello world, we should still have hello world, right? You can see that this ran and then it jumped to a new line, right? So now you've just experienced um, two different methods. You've just learned two different methods to print hello world to your console. You can either use the printf method or the puts method, right? So another thing I want us to look into is the first one is the pre-processing stage. To use the pre-processing stage, we simply use the hyphen e flag and then the name of the file that we want to um, we want to and the name of the file that we want to um, compile. Yeah. So I'm going to append this to a file called C, right? So that has gone through a pre. If you look at this, you can see that we have a file named C. The hello.c file has gone through a pre-processing stage. It has generated a pre-processed file, and then it has redirected that file to a file called C. So let's open the file called C. You can see all these bunch of codes here that will definitely have little to no meanings to you, right? So now the next one is the compilation stage, which simply generates a file with .s extension, right? That's to compile a file and then stop at the compilation stage. Simply use the hyphen s flag and the name of the file, then hit enter. So once that is done, once you check the content of your files, your directory, you should see a file with .s extension, right? And then finally we have the assembly stage, which simply generates object files, right? So to generate object files using the assembly stage via GCC, you can simply use GCC hyphen C and then the name of the file, right? So once you hit enter, it should generate, let me clear this. should generate object files, right? So these object files are very important when you're working with libraries like static libraries, dynamic libraries. So we are going to look into libraries, static and dynamic libraries in upcoming videos. I hope you learned something today. I hope you're excited writing your first program using the C language. If you did, please hit the like button, hit the subscribe button, and I hope to see you in the next video that will be dropping soon.